Hello, grade 7 and 8, and welcome back to another one of Mr. Wensing's science classes. In today's video, we're going to learn a little bit more about solubility and concentration. If you add a spoonful of sugar to a cup of hot coffee, all of the sugar will dissolve. If you add another spoonful, that sugar will dissolve too. To dissolve the most sugar possible, you can crush the sugar into powder and stir it vigorously. At some point, however, the coffee will stop dissolving more sugar. It will have reached its limit. Every combination of solvent and solute at a specific temperature has a limit to the amount of solute that can be dissolved. Solubility is a measure of the amount of solute needed to make a saturated solution using a given amount of solvent. The solvent and solute of a solution can have a variety of different proportions. For example, you can add a lot of sugar or solute to iced tea, the solvent, to make it very sweet, or just a little sugar to make it less sweet. Concentration is a measure of the amount of solute dissolved in a certain amount of solvent. The simplest statement of the concentrations of a solution is in terms of their percentages by weight or volume. Very low concentrations may be expressed in parts per million. A solution containing a small amount of solute is called a dilute solution. A solution containing a large amount of solute is called a concentrated solution. A solution containing the maximum amount of solute that a solvent can hold at a given temperature and pressure is called a saturated solution. An unsaturated solution is a solution containing less solute than the saturated solution. A solution's saturation level usually increases or rises with added heat. When the heated, saturated solution cools down, the extra solute usually separates out as crystals. But if the crystals do not form, a supersaturated solution is formed. A supersaturated solution is a solution that contains more dissolved solute than a normal saturated solution under the same conditions should be able to hold. If additional solute of crystal is added to a supersaturated solution, crystals will begin to form in this solution. How easily a solute dissolves in a solvent depends on temperature, on pressure, and on concentration. In general, raising the temperature of gases lowers their solubility. Heat makes gas molecules move faster, enabling them to escape more easily from a liquid solvent. That's why warm pop goes flat faster than cold pop does. But while raising the temperature generally lowers the solubility of gases, it usually increases the solubility of solids in liquids. For example, 35.7 grams of sodium chloride or table salt can be dissolved in 100 milliliters of water at 0 degrees Celsius. At 100 degrees Celsius, though, the salt's solubility will increase to 39.2 grams. For the same reason, you can dissolve more sugar in hot tea than you can in iced tea. Pressure doesn't affect the solubility of a liquid or solid solute very much, but it does affect the solubility of gases. This is because gas molecules have an indefinite volume and are not connected. So increasing the pressure on the gas forces more gas molecules into the liquid. Henry's law, named for the English chemist William Henry, summarizes the effect of pressure on gases. Henry's law states that the amount of a gas that will dissolve in a liquid is directly proportional or directly connected to the pressure applied to that gas. In other words, when more pressure is applied to a gas, more of the gas will dissolve. When the pressure decreases, the gas will escape. That's why pop gets flat if you leave the top off. The pressure decreases, allowing the carbon dioxide to escape. Henry's law helps us to understand a sometimes fatal condition of scuba divers called decompression sickness, or the bends. The pressure exerted on the liquid gas solutions in a diver's blood increases with depth. At sea level, the diver experiences 1 atmosphere of pressure, equivalent to 14.7 psi or pounds per square inch. But just 33 feet underwater, the pressure doubles to 29.4 psi. At 3,300 feet, the pressure is 1,360 psi. When a diver breathes from an air tank underwater, pressure forces more nitrogen into the diver's bloodstream. Because of the increased pressure, this nitrogen dissolves easily in the diver's blood. But if the diver rises too quickly to the surface, the extra or excess nitrogen in the blood bubbles up. These gas bubbles block small veins and arteries and collect in the tissues, cutting off the diver's oxygen supply. This can lead to nausea, dizziness, pain in the joints and abdomen causing the person to bend forward, which is why it's called the bends, paralysis and disorientation. If the condition is untreated, the diver may actually be permanently injured or even die. A diver can avoid the bends by rising slowly to the surface to allow excess nitrogen time to dissipate. Because the deeper a person dives, the greater the chance of getting the bends. If you do go scuba diving, it's usually limited to a depth of 120 feet.